Division, box method. How can we divide larger numbers using the box method? We have already learned how to use partial quotients to solve a division problem. Partial quotients is when we use logic to find pieces of the answer. The cool thing about partial quotients is that there's lots of different ways you could use it to solve the same problem. In blue, I show how to use partial quotients to take out 100 groups, then 30 groups, then 2 groups, which of course ended up being 132. In green, I showed how to take out 100 groups, then 10, 10, and 12, and still got the same answer, 132. Partial quotients is a great method to use when you're first learning about division because it really shows you the different groups that you're taking out when you're dividing. But sometimes you want just a quick way to divide. That is why we learn how to use standard algorithms to solve math problems too. These standard algorithms are just common step-by-step ways to solve a problem. Most of your parents, aunts, uncles, and even grandparents learned how to divide using standard algorithm. It looks like this. In standard algorithm, you don't really have to think about the groups that you're taking out, but you're going to move from left to right in the number to divide. 3 goes into 3 one time, so I put a 1 at the top. 1 times 3 equals 3. I subtract, that's 0. I bring down my 9. 3 goes into 9 3 times, which is 9. I subtract, which equals 0. And I bring down my 6. 3 goes into 6 2 times, which equals 6. And I have no remainder. As you can see, you get the same answer, 132. That's what we got when we did partial quotients. Standard algorithm is great, but there's a lot of steps to remember. There's a lot of bringing digits down and subtracting and then multiplying. And instead, I'm going to show you how to do standard algorithm in a way that it's organized better to help you keep track of the steps. I'm going to show you how to do the box method. Box method is just a more organized version of standard algorithm of division. Let me show you. In this problem, we're dividing from a 3-digit number, so we're going to draw a box with 3 columns. I'm going to write each digit from my number in a different column. And the number I'm dividing by goes on the outside. Now we're going to play a game. How many groups of 3 go into 3? Well, that's just 1. So I write 1 group on top of this column. 1 group of 3 is 3, so I'll write that inside the column. And I'm going to subtract. Zeros make me happy. That means we can move on to the next column without doing anything else. Now, how many groups of 3 go into 9? 3 groups go into 9. 3 times 3 equals 9. When I subtract, I get a 0 again. Hey, we can move on. Let's go to our last column. How many groups of 3 go into 6? 2 groups. 2 times 3 equals 6. And when we subtract, I get another happy 0, so I'm done. The answer to my division problem is on top of the box. Notice I still got 132 as my answer. What happens if we don't get zeros in each column? We can still divide. Let's try a more challenging one. 1,387 divided by 2. Right off the bat, I think about my divisibility rules, and I notice this number ends in a 7, so it's not going to equally divide into 2 groups. We already know we're going to have a remainder. When I set up my box method, I notice that I have 1, 2, 3, 4 digits in this number, so I'm going to draw a box with 4 columns. Then I'm going to write each digit of that number into the 4 separate columns. The number I'm dividing by will go on the outside of the box. Now we play our game and just go 1 column of the box at a time. How many groups of 2 go into the number 1? Well, none. So I'll write a 0 above, and 0 times 2 equals 0. So when I subtract, oh man, I'm left with 1. Anytime I'm left with a number that's not a happy 0, I'm going to have to carry it up to the next column. So I'll draw an arrow up to remind myself what I'm doing, and then I'll write that 1 up there. Now, how many groups of 2 go into 13? 6 groups of 2 go into 13. 6 times 2 equals 12. When I subtract that, man, I'm left with a 1 again. I carry this 1 up to the next column. How many groups of 2 go into 18? Well, that's 9 groups of 2. 9 times 2 equals 18. This time when I subtract, I get my happy 0, so I don't have to carry anything up to my next column. How many groups of 2 go into 7? 3 groups. 3 times 2 equals 6. When I subtract, I'm left with 1. I don't have any more columns to carry the 1 up to, so that means this 1 is a remainder. 1,387 divided by 2 equals 693, remainder 1. How can we be sure that's right? Check with inverse operation, of course. 693 times 2 equals 1,386. But wait, that doesn't match. Oh, that's right, we still need to add that remainder as well. When we add our remainder of 1, it does equal 1,387. So it worked. Our answer was correct. 693 with a remainder of 1. In this lesson, you learned how to divide using the box method.